Hello, and welcome back to the channel. Today, we're diving into a case study where we'll simulate trucks arriving at the unloading bay. We'll cover all the steps needed to model the process effectively. Without further ado, let's get started. Alright, let's dive into the modeling part. First, open Flexsim and create a new model. As soon as you do, the Model Units window will pop up. This is a crucial step to pay attention to. Once you set the units, you can't change them later, so make sure you choose the right ones. For this case study, I'll set the time unit to minutes and the distance unit to meters, then click the OK button. Now we're inside the 3D model environment. On the left panel, you'll find the library. This is where we'll grab all the components we need for our simulation. Let's start by dragging in a queue. Now, let's resize the queue and rename it to Unloading Bay. Now we'll place network nodes from the Travel Network section in the library. These nodes act as waypoints to guide the trucks. Let's place them step by step all the way to the unloading bay. After placing, connect them using the A connector tool, found on the top toolbar, or just press A on your keyboard and click between nodes. Just like this. Let me connect the rest. At the junction, make sure to place and connect the network nodes just like this. To make the path look more realistic, we'll convert it into a curved path. Right-click on the arrow, and you'll see an option Curved. Select that. Then, use the spline points to bend it into a smooth curve. Just like that. Let me go ahead and do the same for the other section as well. Alright, we're at the junction now. Let's add some curves here too, so the traffic flow looks more realistic. You'll notice green arrows along the path. The arrow pointing in the opposite direction isn't needed, so we'll remove that connection by right-clicking on it and selecting No Connection. Now, the arrow in the direction of truck travel is green, which indicates the default passing behavior. That means multiple vehicles can move along the path at the same time, even if another truck is already there. But in our case, we want to maintain spacing between the trucks. So we'll convert this arrow to non-passing. To do that, right-click on the arrow and select Convert to Non-Passing. We'll apply this non-passing setting for the entire path leading up to the unloading bay. However, there's one thing to keep in mind. At the junction, if you set the curved path to No Connection, it may cause issues when the truck reverses. So in that case, it's better to leave it as non-passing rather than removing the connection entirely. Now, let's introduce a traffic control object to manage the traffic at the junction. We'll place the traffic control object in the 3D model where the junction is located. Next, we'll connect the node where we want the traffic control to be introduced. For the connection, we will use an A connector. Simply select the node at the junction where you want to manage the traffic, and connect it to the traffic control object. As shown in the video. Let me connect the rest. Now, let's go to the Properties section of the traffic control object. In the properties, we need to set the mode to mutual exclusion. This mode ensures that only one truck can be on the path at a time, effectively managing the traffic flow. Next, we'll set the max traveler to 1, which ensures only one traveler, or truck, can occupy the path at any given time. Now, let's move on to the spacing setting. This defines the distance between two objects traveling on the same path. Select the correct connection, in this case, it's the path leading to the junction, and adjust the spacing as needed. You can also check the correct node by clicking on it to display the node's name. Once the name is displayed, you can make the connection accordingly, ensuring that the traffic control is applied to the correct path. Let me apply the same to the rest of the nodes. Now, let's start adding the process flow. From the top toolbar, click on Process Flow. Click on Add a General Process Flow. This will open a new process flow window. Next, from the library, drag and drop the inter-arrival token source onto the canvas. Click on the activity and set the inter-arrival time to 20 minutes, as specified in our case study. Instead of using a task executor, we'll create the truck directly using the Create Object activity. Place the Create Object block on the canvas. Click on its activity. And from the Object drop-down, navigate to Flow Items and select Truck. Now, we need the truck to spawn at a specific network node. To do that, use the Sampler tool, switch to the 3D environment, and select the first network node, here it is NN1. Finally, assign a label to the token by going to the Token Labels section and typing token.truck. This will store the created truck in the label, which we'll reference later using token.truck. We'll also place a sink into the process flow. This ensures that tokens are properly removed after completing their tasks, preventing any buildup in the model. We'll just reset and run the model to check if the truck is being created correctly at the starting network node. I'll also adjust the run speed. And there it is, the truck is being generated right at the starting network node. We now need to set the truck's max speed. For that, we'll use custom code. Place the custom code activity, click it, then hit the green plus button to add a trigger. Click on Code Snippets. From the code snippets, use the set var num command to set the max speed of the task executor. In the command, there are 3 parameters. The first is the object, the second is the variable you want to change, and the third is the value to set. Before we set the variable through code, let's first place a truck task executor into the 3D model to inspect its parameters. Go to the left panel, place a truck into the 3D space, and then head to the top toolbar and click on the tree button. Inside the tree, find the truck object and click on it. This will expand into a subtree. Now click on the variables section, and scroll down. You'll see the variable called max speed. By default, it's set to 120. Now let's return to the 3D model. If you select the truck, you'll notice the property window on the right shows all its attributes, including speed, acceleration, and more. These can be manually adjusted, but only if the truck is already placed in the model beforehand. In our case, since we're generating the truck dynamically using the Create Object activity and process flow, we can't directly set its attributes in advance. So, we'll use custom code instead. In the custom code block, I'm using the setVarNum command. I'll pass token.truck as the object, max speed as the variable, and set the value to 10. This will set the maximum speed of each generated truck to 10 meters per minute. Next, let's add the travel object to the process flow. Just click and drag it into the canvas, then attach it directly below the custom code object. It should automatically snap into place. To keep things organized, I'll rename the custom code object to avoid any confusion as we move forward. Now, let's configure the travel object. Click on the activity button inside the travel object, and from the drop-down menu, choose truck from the token labels options. Next, we'll set the destination. Click on the sampler tool, and reference the network node closest to the unloading bay. In this case, it's this specific node. I'll leave the end speed as it is for now. I'll attach the sync below the travel object to ensure the travel process is correctly included. Let me go ahead and reset the model and run it to check everything is functioning properly. Now, you'll see the truck is generated at the starting node and is traveling toward the nearest node to the unloading bay. Everything is working as expected so far. Next, we'll address the unloading of items, the reverse operation, and the truck's exit procedure. Now, let's move on to unloading the items at the unloading bay once the truck reaches its destination. First, let's disconnect the sync from the flow. You can do this by clicking on the pointer tool and using the scissors icon to sever the connection. Next, we'll add a subflow to this process. Let me rename the subflow, as well as the travel object. To run a subflow, we need both a start and finish point. So, let's place these into the process flow like this. Now, to ensure the subflow works properly, we need to reference it to the start point. Here's how to do that. Click on the stacked flow to select it. Once selected, you'll see an info icon. Hover your mouse over it, and you'll see the sampler item pop up. Click on it, and then reference the start point. This step is essential for the subflow to function correctly, so make sure the reference is properly set. Now, I'll add two create object activities to the flow. I'll attach the first one below the start point. Click the activity, then change the object type to pallet from the flow items. I'll leave the quantity at 1 for now. Next, I'll assign a label called token.pallet to this object. For placement, I'll use the sampler tool and reference the unloading bay. Let me rename this create object. And now I'll add the second create object below the pallet object. Click the activity for this one, and I'll set the quantity to 12. This represents 12 boxes being created per pallet. In the create section, I'll reference the pallet by selecting pallet from the token label dropdown. This will create 12 boxes stacked on top of each pallet. You can adjust the quantity to whatever you prefer, depending on your needs. Lastly, I'll attach the finish object below the create objects. Now, let's run the model and check if the boxes are being created properly at the unloading bay. I'll reset and run the simulation. As you can see, once the truck reaches the unloading bay, the pallet and 12 boxes are created as expected. To replicate the actual scenario more accurately, I'll add a delay activity to represent the unloading time. I'll rename the delay activity. I'll attach below the travel activity. I'll set the delay to 10 minutes. Now, let's focus on the reverse operation for the truck. First, let's place a truck in the 3D environment and check the travel properties on the right. You'll notice that the rotation activity is checked. This allows the task executor to rotate the truck regardless of the path it follows. To control the rotation, let's head to the model tree and inspect the variable that controls this behavior. Click on the model tree, then locate the truck and click on it. This will open a subtree for the truck's properties. Now, go to the Variables section and find the Modify Rotation variable. By default, it's set to 1, which corresponds to the checkbox being checked in the 3D model pane. I'll change this value to 0. Now, back in the 3D model pane, you'll notice that the rotation checkbox is unchecked, restricting the truck's ability to rotate freely. Let's add this functionality to our process flow using a custom code activity. Place the custom code below the subflow process. Click on the activity and rename it. Next, click the plus icon, and from the code snippets, select the set varnum function. Just like we did earlier, we'll use this to change the variable. The object is truck, the variable is modify rotation, and we'll set its value to 0. Now, let's delete the truck and add a travel object to the process flow. I'll rename the object. Click on the activity pane, then select the task executor as truck, just like we did earlier. For the destination, click the sampler tool and choose up to this specific node. As you can see, the path after that node is curved, so we'll need to set the truck's angle accordingly. But before we move on, let's first place a travel object in the process flow and attach it below the existing travel object, as shown in the video. I'll go ahead and rename it. Next, click on the activity pane, set the object as truck, and set the destination to this specific node. Selecting this node will allow for proper traffic control and spacing. Let's reset the model and run it to see how it behaves. As you can see, the truck arrives at the unloading bay, but when passing through the curved path in reverse mode, it's not working as expected. This is happening because of the rotation parameter we set earlier in the custom code. To fix this, we need to add another custom code activity to the process. Let me first disconnect the travel object so we can add a custom code activity in between. Now, I'll place the custom code and connect it right after the truck rotation one step. Let's rename this custom code. Now, click on the activity, then click the plus icon to open the code snippets, just like we did earlier. Here, we'll reset the modify rotation value back to 1. This will allow the truck to rotate freely again as it moves along the path. Additionally, there's another parameter we need to address, flip threshold. To address that, let's place a truck into the 3D model so we can inspect its parameters. By default, it's set to 180 degrees, allowing for a full 180-degree rotation. However, in this case, we only want to allow a 90-degree rotation to prevent the truck from rotating completely from a single node. Let's go to the model tree to inspect the variable. Here, you'll see that the flip threshold is set to 180 degrees by default. Now, let's return to our code snippet. We'll enter flip threshold as the variable parameter and set its value to 90 degrees. Let's head back to the process flow. Now, we'll add a travel object to move the truck to the exit node. Click and place the travel object into the process flow, then attach it below truck reverse 2. Click on the activity, set the executor as truck, and for the destination, choose the last node. In this case, it's this particular node. Let's go ahead and rename this object to exit. Finally, we need to remove the truck from the 3D model. To do that, place a destroy object activity and attach it below the exit travel object. Select truck as the object to destroy. Rename this destroy object to destroy truck. And that's it. Your model is now complete and ready to go. Thanks for watching. See you in the next video.